Well, we'll go ahead and get started here. It's nice to have Hudson Jameson, excellent name by the way, also excellent beard, uh,
Thank you. Thank you.
with us
Thank
here. He's an Ethereum expert who is going to give us a general rundown of Ethereum, the potential that the system has, and do any Q&A that our folks here might have. We've got a number of people in the audience. I think a lot of them are fairly technical, so feel free to dive into technical stuff, and if they want to go deeper, we'll let you know. So I guess, did you have a presentation to screen?
Yeah, super short one, and then we'll just open it up to whatever we want to talk about.
All right, great. Well, I'll hand it over to you.
Perfect. All right, hey everybody, I'm going to go up and pull ahead my slides. Share. Okay, can you all see my screen?
Yep, looks good.
Cool. So you can see I went with one of the default Google slide templates because I'm very professional. So first, let's start with who I am. My name's Hudson Jameson. I've been involved in cryptocurrency and the blockchain space since around 2011. My cat just walked over everything. Oh, God. All right. So, been involved since about 2011 in the cryptocurrency space. I was starting with Bitcoin when I was in college. I mined some on CPUs and did some projects in college around some of the blockchain mining, like made my own little miner and like a dish drying rack with one of the first ASICs. It was a lot of fun. And then I have also been involved in the Dartcoin community. It's now called the Dash community. That was a lot of good times with them, and it kind of helped me look beyond just what Bitcoin could do and see, that other cryptocurrencies could be valuable in the ecosystem. And then I got into Ethereum during the pre-sale. I kind of read up on what Vitalik was thinking of doing, and it really struck a chord with me to have logic put on a blockchain. So I was active in that community. After college, I left for USAA in Plano. I worked in their innovation lab and in one of their insurance departments. So I built the blockchain program out there with some of their use cases and just tried to educate the bank on how they were going to be disintermediated and how their entire ecosystem is going to be flipped upside down in 10 years. And some people did listen to me. USA was actually incredibly cool to me. But in 2016, I kind of wanted to do something different. So I left to do freelance work for the Ethereum Foundation and for just general consulting with clients. So ever since June of 2016, I've been part of the foundation. My role there is kind of a eclectic mix of DevOps, communications, Reddit modding, dealing with the Ethereum improvement proposals, which I will show you guys later, and just kind of dealing with the cross-channel communication. For a time, I did a little bit of PR work, but now we have someone named John Fraser in there who's doing a really awesome job. Aside from the Ethereum Foundation, last November, I got together with a group of people to start a hackathon group called Project Oaken. We participated in 2 hackathons. One of them was the EtherCamp hackathon, where we took water meters, or our version of a water meter using the Raspberry Pi, and connected that to the blockchain. So we had a smart contract that would trigger every time a certain amount of water was dispensed. That won us the Judges Award in that contest. And then immediately after that, in January, we submitted an entry to the UAE Global Blockchain Hackathon, which was about 1,000 people and about 100 teams. And it was the United Arab Emirates putting on a hackathon to see what they could find out about good use cases for the blockchain space. They're very progressive for blockchain. They have land registries and transaction systems being built currently that are supposed to be deployed before 2020. So it's incredibly progressive on their end. We submitted our video, which was we took a Tesla and we connected a Raspberry Pi to the CAN bus port of the Tesla, where there's basically, it's that thing that's right under your steering wheel, and it provides a constant data feed of GPS coordinates, whether you're turning or not, whether you're braking. And with that data, we took an IPFS hash of that data and we put it on a smart contract on Ethereum. And then that was all encompassed in a Raspberry Pi, kind of looks like this, about this big, that had the type of cryptographic primitives needed to sign Ethereum transactions. So we basically made a poor man's hardware security module. With that hardware security module, whenever the Tesla car would go through a toll road, which was basically just an RFID reader, a contract on the toll road would be triggered, and that would cause the identity, this box to figure out, oh, I've been through a toll road, I should check on that, and then it would allow you to autonomously pay the toll bill. So it was like a machine-to-machine communication that went a little bit beyond just storing data. We actually aimed to do the validation of the GPS coordinates. So instead of like, you know, all these IoT devices claiming that a car went through there, you can actually autonomously confirm that using the GPS data that was taken from both the toll gate and from the CAN bus port of the Tesla car. So that won us first place. So we were able to go to Dubai last February for the World Government Summit, and that was a ton of fun. There was a bunch of world leaders and different groups. We won a $100,000 prize, and we got to shake the hand of Sheikh Mohammed, which is like, I guess, their version of like our president. It's a little bit different than that just because of how their political system is, but he was basically the most popular politician in the area. So after that, and we got our $100,000 prize, we decided to turn this into a startup. So we've incorporated, and we're in talks with a few different major groups, and we have some cool announcements coming out during Consensus. So be on the lookout for that, where we're growing incredibly fast. On the screen, we have my wife, Laura Penrod. She's really cute, and she supports me, and I love her. On our right of her is Vivian, one of our 3 cats. Bottom left is Fry, who is blepping. And then that is Lilu on the bottom right. She's the one who's hanging out with me in here. Right now, she's loafing behind me. And in that picture, she has a flower that has fallen on her. So she's acting like she got shot. Because I guess she has never experienced flour before. It's a pretty interesting experience while baking. So, Ethereum in a nutshell. So, in just the broadest of terms, just super general without getting controversial or anything like that, Ethereum is a cryptocurrency and a blockchain platform with smart contract functionality. I think most of you probably know what cryptocurrencies are, but just as a reminder, it's digital currency or tokens or whatever you want to call it that uses encryption techniques to verify the transfer of funds, and it's operated independently without a third party to intermediate any type of transaction. Blockchain, decentralized distributed ledger that keeps a permanent tamper-proof record of all transactions. And then smart contract. They're not really, I think it was maybe Joe Lubin who said that smart contracts aren't smart and they're not contracts, so we don't know why they're called that. But what they really are on a blockchain sense is a protocol that enables self-enforceable, trustless pieces of code. So they're programs that you put on a blockchain that inherit all of the properties that a value transfer on the blockchain would inherit. So depending on how you use the word, it's immutable. It has, you know, censorship resistance. It has the ability to avoid third parties messing with it, and it's very transparent depending on how you set up your blockchain. Oh. And then Google decided, whoop, to stop cooperating. Oh, here we go. So here is a little bit of a visual of smart contracts. They're generally in the Ethereum world, and I'm going to get into this more in a little bit. I'll show some examples of really simple smart contracts and how they're designed, and then how they're compiled down, and how they're published. But how these work are, we have this virtual machine. It's called the Ethereum virtual machine. It's on every client that is a miner that is running the Ethereum blockchain. So as a user of the blockchain, when I create a contract, I write it in a high-level language. In this case, the ones in here are written in what's called Solidity. There's other high-level languages, but Solidity looks just kind of like JavaScript a little bit, maybe with some C thrown in there. And when you write it, it gets compiled down into bytecode. And bytecode is the code that you can put into the EVM. It's a bunch of letters, numbers, just kind of garbled mess that normal humans couldn't read. But once it goes in the EVM and it's included into a transaction, that gets included into a block, and that block is published. And the code on that contract is RAM. On the right, we have kind of an example of what a very simple DApp would look like abstracted out at the contract and function level. So it's not a good use case to just have ticket purchases through a contract. There's probably more efficient and cheaper ways to do that. But for the sake of example, what we have here is a band website where you have a purchase page where you can purchase a ticket for 2 Ethereum. So you do your address and your private key from your public-private key pair that is used to identify you on the Ethereum network. And when you sign it, that transaction doesn't get transferred to another person. It gets transferred to a contract. And that contract has the same type of address as a human address would, or say, like if I generate an Ethereum account, it has the same type of address, but the difference is that a contract not only can hold Ether, it can also hold data. So this signed transaction hits the purchase album function, and when it purchases that logs or runs some type of logic on the contract itself, potentially adding your name to a list of people that purchased it, maybe sending you the code for a download link, etc. So on this next one, enter a mailing address. You send another transaction, and that's to claim the album. When you claim the album, another group of functions happens. The functions can interact with each other. It's literally just like a pretty simple programming language. The other piece of the contract is the storage piece. So you have a list of purchasers you can keep up with. You can store addresses and very simple data structures such as arrays and just regular strings, and make your own data structures from scratch. So that was a super short introduction. I'll probably take questions, do a combination of take questions and dive into some stuff. So this is to get started. I'm going to post these slides later, even though they're super simple, but there's a getting started page on the Ethereum subreddit. And that page has a lot of good information. Well, if it'll ever load. Oh, well, either way, that page does have a lot of good information and a list of things to get you started with Ethereum, including interacting with our development team, talking to other people who are interested in building decentralized applications or dApps, just a lot of good stuff. It's my entire, I'm still on this Hangout, right?
Yeah, we've still got you.
That is incredible. All right. Well,
maybe you're just having DNS problems.
Yeah, let me see what I set my DNS to. But while that's happening, does anyone have any initial questions?
I'll go first.
Sure.
So actually, I thought you skipped over one of the biggest blockchain-related things when you were talking about your wife.
Oh, what is that?
Now, didn't you have a marriage smart contract?
I did skip over that. You're right. So let me pull up that. So maybe, I guess it was a year and a half ago, I put a marriage smart contract on the blockchain. Since I'm not connected to the blockchain right now, it's not going to work. But basically, I could show you the contract. So this is a good example of storing data to an Ethereum blockchain. If it'll pull up. If not, I'll just go to GitHub.
So this is an open source contract that anybody could use to put their marriage on the blockchain.
Absolutely. And I've been meaning to actually update it because it is a bit outdated. Yeah, this is from March 2016, so about a year ago. Oh, either camp's not working. I can still view it on the other one. So I'm going to go to an Ethereum block explorer and just kind of, oh, perfect. So here is my contract address. It has 0 Ether in it. It has 6 transactions. And how I set it up, let me see if I can, you know what I can do? One of the cool things that I like about Ethereum is it's pretty easy to get started once you have kind of the first, as long as you have kind of a good programming understanding. So I'm going to go into Remix, which is an online Ethereum integrated development environment.
Cool. If you're going to show us any text, make sure you zoom in a lot because our resolution isn't that good.
Well, I don't know why, but my DNS is just dying right now. Anyways, I can show you the code on here. There we go. Okay, so let me zoom in a bunch, or everything will just die. Huh. View it on here. Okay, so this is not cooperating. I thought it would. Let's do this then. I'm going to just walk through the contract, and then when the internet's back, I will show it. What we have here, it's just a simple contract, and all it does is store a series of data. So it stores your status, who your partners are, so it'd be me and my wife, the date of our marriage, the IPFS hash to our marriage image, and our marriage proof. IPFS is a kind of a new internet. It's a way to more efficiently, in a distributed, decentralized manner, store and access data and files. So in IPFS, each person is an IPFS node, and if you want to put something on IPFS, you launch it on the IPFS network, and then it's permanently on there as long as someone is storing that file. So I put my IPFS hash to my marriage image on there, and then I put a fake marriage certificate to show proof. But this whole use case was to show how easy it was and how few lines of code it would take to actually store your marriage on the blockchain and transfer it. So you can also apply that to houses and other things that you would have like official government documents for.
So I guess it's worth noting that you were really storing mostly a pointer to the proof of your marriage, right? Not storing like all of the data related to it on the blockchain.
So for the IPFS hash, you're correct. For the actual blockchain, and I think it's finally working, for the actual blockchain, you are storing that data permanently on the Ethereum blockchain. So let me go to, where is it? Remix, yeah. I want to open a fresh instance. So this is the online Ethereum and developer environment. And this contract is old, so it's not going to compile until I do this. You have to set the version number at the top now.
Can you zoom in even more?
Yes, absolutely. Let me get this out of the way.
Is that enough?
Yeah. Hey, y'all got this? Okay, great.
There we go.
0.4 or 0.8. Okay. So this is the Solidity online developer environment. So you just start your contract out with, declaring it a contract. I set up some variables. There's some natives, or there's some things that you can just natively have in your code. So you have integers, you have unsigned integers, you have bytes, and then strings are just a UTF-8 encoded bytes. And then you have addresses. So for instance, when you create a contract, it's visible to everybody and there's no like permissions on it. So anyone can go in and change any of my data. So the very first thing I do is I create a function. This is my constructor basically. Whenever I create this contract, it's going to run this first. And it's called marriage. So I set myself, the sender of this transaction, as the owner. And then I create a modifier. A modifier is just an easy way to not have to do a million if statements every time in a function you want something to be accessed only from the owner. So for instance, create marriage, create marriage, that is only for the owner. So I put that modifier at the end. This function, it's going to take in all of my data like my date, partner names, status, and also push off an event. An event in Ethereum is just a log file that's appended to a block for any contract that has events listed in them. So down here I've declared major event. So anytime I call this thing major event, that will put in the block that something happened that I declared here. So for instance, every time I do a function call, it does the timestamp for when the event happened, the event timestamp for, that's me like actually putting in when the event I'm listing happened, the name of the event, and the description, so it can list it out for everybody.
Cool. Quick question.
Sure.
Question. I'm trying to understand what is the use of this contract, because generally contract happen between two or multiple parties, right? So this contract is meant for what kind of scenario? Maybe it's a contract between you and your wife or any other parties there. Who are the
who executes the contract?
Executes?
Who is the contract for?
What are the conditions you think
well, this isn't a like legally binding contract, right? This is sort of a proof that such a thing can be done. So I guess the question is almost I guess who would legitimize the contract, or who would recognize the contract as a real thing? And I guess that becomes almost more of a philosophical question, doesn't it?
I know the answer is.
Yeah. So that's a good question. So whenever I've talked to other people and they've brought this up, some of the things that are discussed are that with these use cases and with blockchain, over time, as the technology proliferates across all platforms, including blockchain technology, legitimacy, happens. So for instance, all the legal documents you can do on the internet now, if you would have, in the early 90s been like, yeah, all the documents are going to be available everywhere and everyone can access them. It's like you can't really visualize it, but I'm sure laws and regulations are going to catch up to this. And additionally, so laws and regulations are going to catch up, and there's going to be these reputation systems in the future, kind of things like what Blockstack is doing, where you have these decentralized identity platforms, or even Uport, and you have attestations to who is for people to say who they say they are. So like I might attest to my wife being this certain public key. So whenever she does something on Ethereum, I can say, no, that's actually her. Same thing with like a government entity, you could come in, show your ID, and give them your public key, and then that validates you as being on the network for real.
Right, and I'm not a lawyer, but some of the lawyers that we've had actually at this meetup have told us that there is already legal cases in which they have shown that there are processes you can go through to assert that data on blockchains that is time-stamped at a certain time and created in a certain way. If they have the experts come in and say, yes, this is all cryptographically, mathematically sound and all of that, then in many cases you can use data that is in blockchains as like a legal proof of something.
Legally binding.
Yeah, possibly. depending, you know, on a lot of other factors. But you know, we already are at the point where it is being used as evidence in certain court cases.
Yeah, and it's like really funny to me how they, you know, you come into a court and it's like, so do you have the paper document that was signed by this person? And the courtroom gasps because it's like, you have this paper document and obviously they signed it because their signature's there. Whereas literally anyone in the world can fake a signature. So like, that just seems ridiculous to me when we have this type of technology. So I think people will catch on over time. So yeah, just continuing with this.
One more question.
Oh yeah, go ahead.
Yeah, I mean, related to this use case, you mentioned that we are going to upload all the documents, maybe certificate or whatever, along with the contract. So my question is, I mean, are we treating blockchain as a data dumping ground?
Blockchain as a database. Well, I guess.
See, my understanding of blockchain is mostly data which can, I mean, using those data we can correlate some past thing, right? And if we are going to put everything in the blockchain, then I think we are losing the main intent of blockchain, in my opinion.
Yeah, I mean, it's kind of a, you know, what is blockchain really good at, and that's why I think you see a lot of people putting pointers to other data.
Exactly, that makes sense
blockchain.
to me. I mean, okay, you have a reference and blockchain has the some kind of reference, that's fine. But that's a little bit confusing.
Yeah, it's almost a question of like, how do you decide what goes in the blockchain and what you should just point to other data sources, I guess.
Yeah, that's a good question. And it's going to depend on how much money you're willing to spend to store it in there and what use cases you have. So for the majority of like real world use cases, you're going to need a second layer. So for gaming, even for very fast transactions, you're going to need a layer 2 protocol, such as Lightning Network for Bitcoin, or the equivalent for Ethereum is called Raiden, R-A-I-D-E-N. And so that type of layer 2 protocol is going to be incredibly important. Another layer 2 protocol that's being developed for Ethereum is Golem. And Golem is a distributed computation platform that uses Ethereum to help validate and prove that computation happened. But the computation actually does not happen on the Ethereum layer. It happens at the Golem layer. So I think the blockchain is changing from this, you know, let's do all of our logic and all of our transactions on it, which some people early on thought had to happen, to blockchain is the final destination for finality and the final destination for what is the source of truth and whatever type of transaction data or value that you have.
Yeah, I mean, I think one metaphor I like to use a lot is sort of anchoring metaphor. And so, you know, you can anchor other layers down into the main layer, and you're just balancing all these trade-offs of cost and speed, right?
Yep, absolutely. So yeah, I pretty much went over, like, I went over a function, I went over starting the contract. The rest of them are just real simple, like set status, it sets the status. Set image, set marriage proof. And yeah, that's the gist of the contract. If I go back to the blockchain, it will, because I put the code in on here, you normally can't do this with contracts, but I went to the site and put the code in, so I can actually read values from the contract. So this image hash in here is an IPFS hash, and it is in there forever. Same thing with my marriage status. This is a bytes 32 entry, but if I were to convert that to hex, or sorry, to ASCII, that would say married. Same thing with this. This would say Laura, or this would say Hudson, and the other one would say Laura. And then the ownership address is the address I created it from, which will track, like in the blockchain, can track all of my transactions, all my creations of a contract, and etc.
So I think this leads to an inevitable question of, you know, I certainly wish you the best in your future endeavors and in your life, but what happens if you need to change this contract?
So there's actually a function in there for that. So let me pull it up. So in marriage, remember I had this modifier called only owner. So only owner means that if that is attached to a function, then only the owner can do anything with it. So for instance, set status. Set the marriage status if it changes. So I have it as only owner. I put in the basically the UTF-8 characters that establish what my status is, and I launch an event in that block that says, hey, this contract, something happened to it, the status changed. So because I still have ownership of that Ethereum account, I can change the status. And it's worth mentioning that when people say that smart contracts can't be changed, or smart contracts are immutable, or smart contracts, once you put it in there, you can't do anything with it. It's true that you can't actually change any of the core framework of the contract. Like, you can't go in and change the name of it, or you can't go in and change the functions. But any piece of data in here that has been declared as a variable can be changed. So the address can be changed if I have a function that is set up for that. I don't in this case. But for instance, partner or marriage status, that is something that I've set up a function for, so that if I'm the owner, I can go in and change it. If I didn't have this modifier in there, anyone could call this contract and change that status. So that doesn't mean that the history of it is erased. All that means is that there is an entry appended into a future block that is different from the block that the contract was launched from, that says, this is the new information, this is the new status of this marriage contract.
So will that basically give you a redirect to the new hash? Because any change that you have, it's going to be a completely different hash.
Yeah, how does the pointer update work?
Yes. So right here, this contract was launched 412 days ago.
Can you zoom?
Oh, go ahead.
Can you zoom?
Yeah. Is that good?
Yeah.
So here is the initial transaction that set it off. This transaction, called this, it's, okay, so enter marriage proof in IPFS is one of the things you can decode from this, but I put in a block of input data into this contract transaction, and it created it per my standards. So it put in the initial stuff like the status and the marriage names and all that stuff. So this happened 412 days ago. I did an update to it, and in that update, I called the function marriage proof. Well, let's see what that function actually does. So marriage proof puts an IPFS hash that's a pointer to a document in IPFS. So when I called that when I did that transaction, it updated that data into the next block, so that when I go to the actual contract in the Explorer, it just shows the latest data. The same thing happened. The same thing happened 384 days ago. Whoops, wrong one. Was it this one? Oh, maybe someone else tried to contact it. Oh, set image. Here's another time. So image used to be all zeros at the point before this 412 days, 48 minutes ago. But once I put it, it was added to this block with a group of other transactions. And so when you're viewing a contract, you want to view it at the point, or view it from the latest block. So because this blockchain has all of these contracts and all this data, I would want to go to the latest block and see what the change is. So you can go back in the history and see what the data used to be, but for most use cases and for most of the time, you want to just see what the latest stuff is. So did that answer the question?
I have another
Yep.
question. If you find a bug in your contract, can you update the contract, or do you have to replace it with a new contract altogether?
Right, yeah, so I guess is there a contract migration path or scheme that people have been using to transition from one version of a contract to a new version?
Absolutely. And so let me pull up. So for my other role at Oaken, we have, let's see. So that Tesla use case I talked about before, and I'll post a video to that later, that was done using Solidity for smart contracts. So we have 4 contracts here. We have the Tollgate, the toll user account, the Tollway Manager, and the vehicle directory. The Tollway Manager, I'll just take this contract and put it so we can see some good highlighting here. So here's Tollway Manager, and what it does is it says, I'm going to import the code from the Tollgates contract and the vehicle directory contract, and every time I say create vehicle directory, it will create a new vehicle directory, and every time I say it'll create a new tollgate, it'll create a new tollgate. So what this does is it's a factory. It's a factory for tollgates and for even for users. So as a city, if I'm like installing a toll road and I'm like, all right, I want to do a toll road system that's built on the Ethereum blockchain. The first contract I'd launch is this manager. I'd have the code for the tollgates and the vehicle directories, but those pieces of code are going to have specific things in them. And let me find one example. Decommissioned. I have a Boolean that I set in the contract called decommission. So if I want to decommission this tollgate and launch a brand new one, or even decommission the Tollway Manager contract and launch a brand new one, I can do that and still put functions in here to point to the new one. I didn't in this case, but for upgrading contracts, that's the easiest to implement scheme, is to just have a flag in there for when it is not active anymore, and then point it to the new one. In my Tollway Manager, I have an address called VD, which is vehicle directory. For this tollway toll booth use case, I have an entirely separate contract called vehicle directory that is just a storage contract. And the reason I did that was because we don't want our storage and our logic becoming intermixed. Because then when you need to do updates or when other contracts need to access your contract, it gets really complicated really fast. So say I'm with, this contract is Tollway Manager and I have a vehicle directory, but then I want it to expire every year. Like that directory doesn't matter anymore. All I'd have to do is say set VD, and I would put in the new address to the new contract address that is the most up-to-date vehicle directory, and then the new one, or the old one, is just kind of in the ether. It's not around anymore. You can also do things, there's very, very advanced stuff you can do for upgrading contracts using bytecode directly in the contract. That's kind of advanced stuff, and not a lot of people are doing it right now just because the entire platform's a little bit, still in heavy development, so they don't want to do anything that is going to be too complicated, most people would say. There are some people I know who are just very, very good at contract development, and they're able to do it though.
Yeah, so it seems to me that a sort of recurring theme with smart contracts is that you have to be very forward thinking when you're initially designing it, and design it with, paths for extensibility and upgrades and security. Like, for example, I know, like with the DAO, like one of the reasons why it wasn't even worse disaster was that they had some sort of pause and timeout requirements in there that prevented the hacker from being able to just run off with everything immediately, right? So those type of escape hatches and slow down, like cool off periods and other type of forward thinking logic that can help you with these different things is kind of important to start off with as a foundation, right?
Absolutely. The DAO really spurred a ton of research into those type of strategies and into smart contract security in general. So when you look at this contract, like there's no escape hatch just because it's not holding any real value, but contracts that are out there today that are holding any real value, that are taken seriously, have escape hatches. And what that means is I have a function in here, and in about 20 lines, I could code up a really simple, easy to use multi-signature scheme. So what that means is there's a list of addresses, and it's me and 5 people that me or the community trust. And if something goes wrong and we need to pause all the functions in here, we just have to set a modifier that says, is it paused or something? And so if that group of multi-signature holders, like maybe 4 out of 6 multi-sig, if 4 of the people in that list say, oh, something went wrong, we need to stop this, then the whole contract can pause. Same thing with extracting money. Like if a smart contract is being drained of funds like the DAO was, there's better systems that like limit how much you can withdraw a day. Or in the DAO's case, they had a waiting period of like 14 days for proposals to the DAO and then 30 days for what they would call splits to happen. So there was 44 to 46 days in there that the community was able to react. It might have actually been less than that. I don't know if I have the numbers right, but basically, yes, there was a delay, and it really helped in the response time. So since then, that's a big security thing. The other one is formal verification, which is a topic that goes way over my head, but it's taking a contract and putting it through a very complicated piece of software to make sure so that it can list out all the possible things the contract could do. And the reason for that is there's very specific bugs that kind of come with the fact that you're putting a semi-Turing complete virtual machine on a blockchain, where you need to know, okay, I have all these functions in there. Are any of these prone to reentrancy attack, for example? Reentrancy attack, all that means is you have a function and you have a function that is updating the data before the call ends. And so you can call a contract multiple times and get it confused and cause it to repeat logic. So you can have it run through formal verification. I think, and it's called Y3 here. Yeah. So it's still in development, but you can do static analysis and look at things like different very Ethereum specific economic issues that you could run into when you're running these contracts. So that's being developed incredibly fast. The DAO happened almost a year ago, and we've come a long way in the security of smart contracts.
Question.
Okay, go ahead.
So when the contract is can be written by anyone, like as an owner, but when it's executed, the ownership is joint, right? So when there's a joint ownership on the contract, how do you specify that? Because it could be like you're talking about changes to the contract and updates to the contract, right?
So how do you specify joint ownership of a contract? I guess, are we thinking like a sort of multi-signature scheme almost?
Yeah. So on this, on my marriage contract, if I wanted like me and my wife to be able to be owners on it, all I'd have to do is say if message sender equals owner, or, so then it would be like an or message sender equals my wife. And my wife could be an address I create up here. So address my wife. And all I have to do, I make it public so that people can, it's easier to read the contracts when the variable is public in certain block explorers. But when I create my marriage, I can say my wife, which is the variable I defined up here, that address is equal to, I'm just going to put a junk address, but I can put in whatever address I want at that point, or I can even submit it into the function. So that's like a very simple way to do multiple ownership or multiple edits. You can also make this so that things can only be modified if both of you agree to it. You can also do things if 50 people in a list, however percentage agree with it. So it's very flexible with the ownership capabilities of smart contracts, but it's not built in for you. If I were to release this without this owner equals message sender, anyone could go in and do anything they wanted with this contract.
All right.
Yeah, so regarding the new version of the contract, right?
Yeah.
So community is thinking about the live migration of the contract. For example, I have contract set up. I have let's say 1,000 people have a contract set up with the old contract solidity code, and now we have a new version of that same contract. So how we are going to migrate those existing contracts?
So yeah, so if you have a large number of contracts with a large number of individuals using them, how do you migrate them all over?
Because decommissioning is basically what you're saying, okay, for a certain period of time, you're out of contract.
Right. And I guess it would depend on how you have the contract set up, though. Isn't there also general concept of like having stubbed contracts?
Mm-hmm. Yeah, so there is that concept. That's one way to do it. As far as like, so maybe like there's 100 people using your contract at any given time, and they're doing a ton of transactions and a lot of stuff's going on, and you need to migrate it or stop it. The cool thing about blockchains in general is that when you have a transaction come in, it comes into a block, and then it's waiting to get mined, and then once it gets mined, that's the new normal for that contract or for that transaction. So maybe people are doing a ton of stuff up to 116.2841, but then if I just put in the command to stop the contract temporarily or migrate at 116.2842, anybody from that block on can't do anything. And within the block, if there's multiple calls to the same, here's the block, so parent hash, 3 transactions. So here are all the transactions in the block, and they're also in order by, I believe at least in this block explorer, they are in order by when they were executed. So as soon as you submit the transaction, it's going to go in the queue, and then as soon as it hits the blockchain, then that's the way it is. So if you wanted it down to like, and also the Ethereum block time right now is between 12 and 16 seconds. So if you needed something that was more granular, like you need to stop something in a millisecond, that's where these layer 2 solutions are going to come in, because you can have a bunch of transactions going back and forth on a layer on top of Ethereum, but then whenever you need to stop that system, you can send a transaction to the main Ethereum blockchain after pausing it at the second layer. I mean, I think in the future there will be under 4-second block times in the next year and a half, and then potentially sub-second block times in 2 years or more, based on what the research team has been saying lately that they've been able to come up with.
So are there any, I guess, time or block height based mechanisms that you can use for switching logic or upgrading versions, or trying to coordinate amongst large number of people?
Yes. So for many of the so for instance, let me just go to verified contracts. So here's an example. I don't actually know what this is, but who ran this contract or anything. I just picked a random one. But this is a token contract. So y'all have heard about ICOs and crowd sales and stuff lately. So I'm going to pull this up here. We'll walk through this once it loads. Okay. So safe math is a contract that people can pull from in order to safely add, divide, multiply, and subtract without any vulnerabilities happening. So let's get to the actual crowd sale token. So there's a lot of, when you're doing a crowd sale, you need things like a maximum funding goal, how much you've raised, who the beneficiary is. So in this case, it would be a multi-signature address. And then this start time is the interesting one. This number right here is a Unicode, sorry, not a Unicode, a Unix epoch timestamp. So let's look at what that is. So if I put this into here, it's going to give me a human readable one. So that means that on Tuesday, May 2nd at 12:17 GMT, something's going to happen. So let's go and see what happens then. So where else is start happening in this contract? Here we are. So inside of invest, if I'm an investor and I am sending Ether in order to invest in this crowd sale, this function is going to go through some checks. It's going to say, has the crowd sale closed? This is a true or false variable. So if it's closed, you can't. It's gonna do a throw, and a throw just means stop the contract, refund, or stop the contract and refund the Ether that was sent. if now is just a global variable, and solidity, that just means what is the epoch time, what is the epoch time that the blockchain is telling me right now. If that's less than start, which would be before the start time. So actually I said that incorrectly. This epoch time that I just converted, this is the start time. So if anyone tries to access this smart contract before that start time, it's going to throw an error. So that is kind of how you do time-based stuff in Ethereum. And so blocks are the epoch time that is appended to every block. So it would look like this in here. So it automatically converts it in here. But if you go to the actual block, yeah, the timestamp's already converted. But each block has a timestamp, and that is an approximate timestamp. That's not exact because as a blockchain, as a closed environment, it does not have access to outside information without the help of others. So the miners just come together and they all give their computer clock times, and that makes this. So it's close enough, basically, is what I'm trying to say.
Cool. Any other questions?
Yeah. So real quick, I wanted to just show you guys the thing I'm most excited about right now, which I probably shouldn't be because it's incredibly boring.
Sure.
But Ethereum improvement proposals. So Bitcoin has Bitcoin improvement proposals, and Python has their improvement proposal process. And so what we're trying to do with ours is make it a little bit more blockchain based. So right now, how this works is you have an issue and you want to do something for you want to make a change in the Ethereum blockchain, and so you want someone to go over your proposal, look over your specification, and comment on it. You do that in the issue section, and then when you're ready for it to become an official improvement proposal, you put it into the PRs. So it's a little bit similar to how Bitcoin does it. So someone made a document that is to describe what the deterministic wallet scheme would be for Ethereum. And how we do governance so far is still really, really bad. Like, it's really hard to do blockchain governance. So what we've decided to do is the core developers, since we're still pretty small and we are all kind of friends, we have meetings every week that are called core developer meetings. They are, we have a repo where the core developers from all the Ethereum clients meet. It is recorded on Google, and then notes are published based on the agenda topics discussed. And generally, it's going through EIPs and saying, is this a good idea? Does the community like this? Should this be implemented? So that's how we do it today. In the future, what we want to do is have contracts on the Ethereum blockchain that can, you can basically register your GitHub name, attach it to an Ethereum address, and vote on the Ethereum blockchain based on which EIPs you want to go in, or if there's a controversial topic like the DAO fork that we used to have, and have it be blockchain based, including a liquid democracy model where you can have a group of people. So if you're at like a group of miners or a group of like the core developers, you can have your own little group in that liquid democracy so that you can all assign your votes to that one mega vote. So you can have a bunch of different governance schemes based on that. There's also other signaling methods we've been looking at, and we're still really early on, but I'm just really impressed at how the community deals with this kind of thing. Not to bash Bitcoin too hard, I still love Bitcoin, but right now there's a lot of issues with their governance structure. And I just think that Ethereum is doing everything it can to avoid some of the things we're seeing from the Bitcoin side. So I just wanted to kind of point out what we're doing to kind of try to make it less controversial when we have topics that need discussion.
Yeah, I mean, I think it's kind of the difference between having a governance structure and not having a governance structure.
Yeah.
So is there any reward for the proposal or something? Because the reward currently around 1.5 years before there was some reward when you tested. Or,
Oh yeah, I guess are there bounties or rewards for Ethereum improvement proposals?
Yes, so we have, oh, let's see, Ethereum Git. So wait, status, Ethereum GitHub poll. So there is a bounty smart contract that is, I'll be able to find it later. Basically, someone has made a smart contract for doing GitHub pull request, and that being associated with getting Ether for whoever wants that. There's also one, we have a whole Stack Exchange where people can ask questions, and some of these questions that are unanswered and are very difficult have bounties attached to them, is my understanding. So you just associate it through an Oracle contract that talks to the blockchain, and whenever it's answered, it pays out to whoever answered it. For the EIP specifically right now, we don't have bounty contracts for EIPs. I guess what's an example of a bounty contract for our EIPs that you were thinking of?
No particular examples. I think you.
Oh, I see. So no, but yeah, we have some incentivization that we're thinking about implementing, but right now, everyone's nice enough that we don't have to do that. And if we just ask people their opinion or for them to complete something, they do it. A lot of that's kind of just driven by the want for Ethereum to kind of stay on the cutting edge of, innovation and improvement in the blockchain space.
Hudson, I have a question
Yeah.
about just the transition from proof of work to proof of stake.
Yeah.
Being discussed. I mean, obviously, you guys have tons of researchers. You guys are putting tons of time and energy into it, making sure that everything goes as smoothly as possible. What are some of the bigger discussion points that come up in the transitionary process?
So, the Ethereum Foundation funds a research team. We're not the only research team. There's other larger groups in Ethereum that that research some of these topics. But generally, many of the people come to a Getter channel that's called Research. And that's the one where everybody kind of talks about the direction we're going. There are some core people such as Vitalik Buterin and Vlad Zamfir who hang out here a lot, and they kind of collect some of the things that are talked about here and formalize them into things like protocols. So we have Getter for a lot of our communication, and then for actual implementing of the stuff. Actually, I can look it up. So the proof of stake instance that we're researching is Casper. So looks like Vitalik was in here. So this is just a stage 1 Casper contract. This kind of talks about, or this has a Python script to kind of run an example Casper. There's also blog posts, mostly by Vitalik, but also by others, for implementing Casper, for defining it throughout the research channel. Oh, there's actually a lot of updates here recently. This used to be pretty stagnant. So each version of Casper is implemented in GitHub, generally by Vlad or Vitalik or other researchers. How we're going to handle proof of stake is this. Proof of stake is incredibly difficult, but we have solved a lot of the main problems in theory, and we're in the process of formally proving that some of the mathematical assumptions made and some of the economic models that have been described about Casper are correct. Yoichi is a researcher who specializes in, I guess, figuring out correctness of different mathematical theories and stuff like that. Again, this is like way above what I know, but he's been working on proof of stake. And what we're probably going to do is we have 2 planned development phases. So the next one is called Metropolis. That's going to be, wait, let me go back to where everything is. So EIPs. So for Metropolis, we're having a number of changes. All of them are in these accepted EIPs planned for adoption. So we're going to be doing some abstraction to how the transactions are made to get ready for proof of stake. We're also going to be including certain cryptographic primitives to be able to do Zcash style ZK snarks in Ethereum. And over time, as we improve the VM, that's going to be even cheaper and easier to do. But for right now, just a lot of these new operation codes at the EVM layer are going to facilitate that. Oh, actually, specifically, EIP 196 defines a precompile contract, which is just a contract that is stored at everybody's client, so they don't have to run the logic on chain to do complex cryptographic stuff like SHA-3 and SHA-256 and elliptic curve functions that are required for ZK snarks. So Metropolis is, end of June, maybe. It's going to be around that time. We don't usually set hard dates because we like to have a ton of time for testing. And then the phase after that is going to be called Serenity. Serenity is going to be multi-stage, and Serenity is going to have proof of stake and sharding, probably proof of stake first. And so there's going to be a hybrid proof of work, proof of stake that goes on at the same time, where blocks are going to be validated by both proof of work and then separate blocks by proof of stake, and then potentially cross-checked with each other. And then as we prove out proof of stake during that hybrid phase and make sure that it's stable and doesn't have any flaws, then we're going to drop off proof of work completely is the current plan. So did that answer your question about kind of how we're doing it, or I can get more detail as well if you need?
Yeah, can you explain ZK snarks under a minute?
Oh, wonderful. All right. So ZK snarks, there is an excellent YouTube video from the Triangle meetup that Zuko was on 3 weeks ago, and I think he explained them very well. But it is a way to prove to someone that you have information without revealing that piece of information. So you can do completely anonymous transactions that are just between you and the other party. So you can have true privacy on the blockchain, at least at the transaction layer. And Zcash was the first blockchain to fully prove that out and have like a secure setup. In Ethereum, you can take the setup parameters from Zcash and plug them into Ethereum to have your own Zcash style ZK snark transactions. So maybe I want to prove that I know your wife's name without revealing your wife's name. You can do that by some really complicated math magic. Yeah, if you can reach out to me on Twitter, I'll post a few links to some Zcash and ZK snark articles that I found interesting. I still don't fully understand it though. I think Zuko's talk from a few weeks ago is your best bet.
Yeah, no, that's a good response. Do you think that fundamentally, I think just in the terms of just valuing Zcash's blockchain, does that it seems to me like that might compromise some of their project to partner up with Ethereum in that way.
That's a really good point. And so Zuko talked to us a little bit about that before he went out on this. He was actually, by the way, Zcash and Ethereum are like best friends. Like we love each other's teams and we, meet up at conferences and stuff. Same thing with the IPFS guys. But specifically, there was a conversation between Vitalik and Zuko because Zuko kind of asked generally to the public, what is why is it that we have ZK snarks on Ethereum, and will that lower the value of Zcash? And what Vitalik said was, I'm going to find it in a second, but the gist of it was that Zcash is for specific value transfer. Like you can create a token in Ethereum. I can create a token in a smart contract very, very quickly, but that's not going to actually it's not going to actually do anything. It's not going to have any intrinsic value like Zcash does. when you create a ZK Snark transaction in Ethereum, it might be as secure as the ZK Snark setup, but it doesn't have the backing of the Zcash blockchain, and it also doesn't have the here you can find it on here. Tweets and replies.
Yeah, Zcash went to extreme lengths to do their quote-unquote trusted setup. So
Yeah.
That would also become a question, I think, of the strength of whatever the setup of your ZK Snark scheme is. But also, I would think that if you're doing any zero knowledge stuff on Ethereum, that's probably going to be relatively costly, right?
Yes, that's correct.
Data sizes involved with that.
Oh, here. People are asking, what's the point of Zcash if Ethereum is going to have snarks? How would you answer? I'd say Zcash can still more easily make dev trade-offs to optimize their use of snarks. So exactly what you just said. It'll be expensive. Parallel validation, quickly upgrading to better snark protocols, and 100% focus on the surrounding infrastructure is a plus. So really, Zcash is a blockchain that's really good at what it does. Just like Bitcoin is a blockchain that was really good at what it did for instant transactions and is now really good for a long-term storage of value, even though it may be volatile or what have you. To your point on the setup for Zcash, they had this complicated setup where they had 6 people each have a piece of the key that was used to create the parameters around the ZK Snarks and Zcash. And that parameter can be imported into Ethereum. So you would literally have the same type of ZK Snark or the same type of Zcash transactions with the same amount of security in Ethereum as you would with Zcash. Additionally, because we support all the cryptographic primitives of Zcash in Ethereum, you can do things like a two-way peg or certain types of two-way pegs. So you can maybe, this probably wouldn't work be very useful, but you could have transfers of Zcash on the Ethereum blockchain and potentially vice versa, depending on what Zcash does in the future with their development. I haven't heard any plans on that in stone, but if you want to know more about that, there's a whole thing called Project Alchemy, and it's a collaboration between, it's actually on both of our blogs, Zcash and Ethereum. And it's called Project Alchemy. So it's going to enable a decentralized exchange between Ethereum and Zcash. So you can trade the coins on both protocols, and you can facilitate development of applications both on Zcash and Ethereum. So you can pay for contracts to be run on Ethereum using Zcash tokens, and you can maybe create Zcash transactions using Ether tokens. Is, I believe, the end goal of that. Alchemy is much bigger than that, though. Just go ahead and read this this blog post, and you can see what our teams are doing to kind of intermix the protocols.
So I think that's an interesting point about trade-offs of having a highly specific blockchain that can optimize for the things that it's trying to do, versus a highly general blockchain that's trying to be platform of everything to everyone. Do you think that the sort of generalization that Ethereum as a virtual global computer is going to cause unique scalability challenges, I guess, as opposed to blockchains that are more specific in what they're trying to do?
Oh, absolutely. Because we are a general purpose blockchain, and unlike Bitcoin, we're not. So Bitcoin is just about, like, it's just used for value transfer. There are contracts on Bitcoin, but they're very limited to multi-sig and a few other cases. You can basically, if you want to do something on the blockchain that requires a lot of coordination and a lot of scripting and code, you'd want to use Ethereum. But with that comes the challenges of, where are we going to store all this data? How are we going to make economic trade-offs for this computation? So part of the answer to that is proof of stake. So getting rid of proof of work miners altogether, which helps on energy cost and is also arguably more safe than proof of work, the way we're designing our proof of stake implementation. And then additionally, for scaling, we have something that the research team is also working on called blockchain sharding. And if anyone pings me on Twitter, I can give you a really good video on explaining it. But basically, we have kind of come to the conclusion that just like the internet doesn't need every single person to have a full copy of it to operate, we don't think a blockchain needs everyone to have the entire copy of the entire blockchain. Most of you, if you have a Bitcoin wallet on your phone, is using some form of a light client. So that's kind of proof right there that, I mean, depending on what you're using the blockchain for, you need different levels of trust and different levels of trade-offs that you take for the, having space requirements on your phone, for instance. So in Ethereum, what we're doing is we believe that we can design and partially design a system to have these shards of blockchains. So each kind of like pseudo-independent blockchains that all cross-communicate with each other, so that people who are validating the blockchain or storing the blockchain and acting as nodes only have a part of the blockchain, and then they cross-communicate with each other. And that adds a whole level of complexity and also a whole level of complexity around the incentivization layer of, why would people store that data? But those are active research problems we're working on. So to answer your question, part of it's going to be just good development work. Some of the EIPs that we have in here deal with abstracting different transaction elements and refactoring block hashes so there's less space taken up. So with the improvements in the virtual machine, coupled with sharding and coupled with other things we have in the roadmap for scalability, I think we're going to be okay, as long as tomorrow everybody doesn't use the Ethereum blockchain at the same time. So we just got to innovate faster than the public wants to use us.
Gotcha. All right, another question.
Great.
My questions are more around the speed of on the secondary layer, like on the Ethereum Enterprise Consortium. What's your transaction time and block speed? And then what you mentioned, the multi-chain communications and sharding of the data. What's your projected transaction speed on those type of operations?
So with the Alliance, what they're dealing with, which is again it's separate from the Ethereum Foundation, but I know a lot of people there, and they're really great people, really awesome, intelligent devs working on this, and they focus more on what some people call private blockchains. I call them consortium chains, and what that means is that it's a blockchain where it has all of the elements of the block of a normal blockchain, except the consensus layer is swapped out. Instead of proof of work, you have a consensus model that is more permissioned for small groups of people to validate transactions. So for instance, if I do a consortium chain of 10 banks, I wouldn't use like proof of work because everyone knows everybody. The reason that you have a consensus mechanism like proof of work is that you don't trust everybody who's participating. You don't know the identity of everybody who's participating, and you need some assurances that things are going to happen. If you have 10 banks, already they're operating in their silos, but cross-communicating today with a certain level of trust. It's not a lot of trust, but it's a little bit. So for a consortium chain, instead of having transactions go and every time a block needs to be created, a bunch of work has to go into it, they have things like proof of authority or round robin protocols. So proof of authority is in here, or one version of it. Proof of authority was originally coded up by Gavin Wood, if I recall. And that was put in the parity client. Oh, where is it? Might be on 2. Tangerine whistle. But anyways, so this proof of authority, you have 10 validators, and the validators just take turns adding blocks and approving of them. And everyone can see the transactions being added. So really, there's no need to do any kind of mining. And so when that happens, block times are sub-second easily. Now for throughput and scalability, that depends on how you code your client. There are some blockchain clients in consortium settings that can do thousands of transactions per second. And that's something where a lot of people are coming together and coming up with these schemes to get more transactions into blocks. And it's easier to do in a consortium setting because you all trust each other. That trade-off isn't there anymore of that trust layer. You at least somewhat trust each other. So this is proof of authority, and this will, if you are interested, it's EIP 225, and it kind of defines what it means to be in a proof of authority system.
Cool.
Hudson, do you see a lot of the consortium chains paying close attention to what you're doing, especially around like you said, TPS? Like they can do 1,000 transactions per second on their own chain, but especially around like the Raiden network developments, which I don't know if your estimates on what the TPS is at this point. But
I don't know the Raiden TPS, but I would say that yes, there's a lot of, so the Enterprise Alliance is headed up by a group of people who have been in close contact with the Ethereum development teams. So for instance, JP Morgan made a consortium style blockchain that can live inside of a public blockchain, is my understanding. It's called Quorum. It's a really awesome piece of software. And that was developed in conjunction with ETH which is a group of developers who create our Ethereum Geth client. There was also included in that is Block Apps. They created I think it's Haskell implementation of the Ethereum client. So I didn't mention this early on, but we have, let me check this out, but we have Homestead Guide. We have 7 or 8 clients, I think, that run Ethereum. So for instance, Parity just came out with a Bitcoin client the other day. There's the Bitcoin C++ client, there's the Bitcoin Node.js client, and in our case, we have a Python client, a Go client, a CPP client, a JavaScript client, a Java client, Haskell, Rust, and Ruby. So all these are mostly up to date with what the current blockchain is doing. The ones that are definitely the most up to date are the Geth client and the Parity client, so Rust and Go. Oh, it is dinner time for my cat. If y'all are hearing that, that's her automated feeder. But to answer your question, yes, the Alliance is going to probably develop their own client or modify a client in order to put the swappable consensus in. And they're also going to contribute any of their, or my understanding is that they're going to contribute any of the stuff that they develop that can help the public chain and contribute it back to our repos. So it's more of a collaborative effort where if they find some breakthrough in getting transactions per second higher in the near term, beyond a second layer protocol like Raiden, I think that they would contribute that back to us. So it's a collaboration between those working on the public chain and those working on a lot of the enterprise stuff. So I'd say it's a good relationship right now. Time will tell if it's going to turn into something that's more one-sided or the other, but I see there's a lot of good people at the Enterprise Alliance that I trust will work with everybody involved in the ecosystem on making Ethereum better.
All right. Yes.
I got in late, so I apologize if this has been addressed already. My understanding of the Ethereum token itself is that it's meant to be a form of fuel for the Ethereum virtual machine. That's not always what I use it for, but I'd like to sometimes that I'm subversive. With Ethereum passing $80 and Ether tokens approaching 100 fairly soon, how exactly does this impact the cost of running the virtual machine? And is there a worry that the token would become too expensive to actually run a certain DApp or smart contract? And are there ways to mitigate that?
Oh, good question. So yes, the price has been going crazy lately. So Ether is not a cryptocurrency token in the way that Bitcoin is, because Bitcoin is a store of value that can be transferred from person to person. Ether has that quality, but it was built to be a utility type cryptocurrency or a utility token. When you have Ether and you make a transaction on the Ethereum blockchain, that Ether is converted into what we call gas. Gas is used to run transactions. It's a way of thinking about how complicated that contract is and how many functions you have to run in it. So if you're doing a contract that runs like that does 1 + 1 = 2, that's a lot more simple than doing a contract that does a ZK snark. So they're going to have different amounts. Miners on the Ethereum network have a price they're willing to. They basically price out the gas price in terms of Ether. So as a miner, I say it's going to cost you 0.001 Ether per unit of gas that you spend. So if an addition computation on the blockchain costs 100 gas, that's a really small amount of Ether. If it's a ZK snark and it's like 10,000 gas, then it's a lot more. So yeah, gas cost is a static value for computation, and then the price is flexible depending on what the miners set the gas price to be. So as a miner, you can set the gas price higher or lower depending on the change in the cost of an Ether token in real life. I don't know enough about the crypto economics behind it, but this gas and Ether section has some good notes, and there's also stuff in the Stack Exchange that kind of explain it.
Right, so there is basically a market of sorts of people saying that they're willing to bid a certain amount for a certain amount of computation, right?
Yes, exactly. And there's some miners that'll do things for basically just the at cost, like just the gas cost. But there's always a minimum that you have to run. It's not like I can't negotiate with a miner to send 0 Ether for a transaction. There's always a minimum that's tied to the static value of these gas costs in a transaction.
How does that change with proof of stake coming on? Obviously, there won't be miners making the decision. Who does make the decision at that point?
That would be the group of validators. So kind of a rough, and this is early, so this could change, but the rough way that proof of stake is going to work is you got to have a deposit of Ether. So I want to be a validator and I have 1,000 Ether. And so I lock that Ether up in this contract that's the Casper proof of stake contract. And I have a chance to be one of 100 or 1,000 validators. Maybe let's just throw out a number. Let's say 10,000 people want to be someone who is staking their Ether into this proof of stake system and validating transactions. A lottery happens every so often, maybe every day or every few hours, where new validators are chosen at random. This is done so that there's a validator pool and then selected validators for that time period so that validators can't collude as easily. The deposit is locked for 3 months after you become a validator. So if you stake your tokens in this proof of stake system, you can't immediately pull them out. You have to declare that you're leaving, and then you have to wait a little bit. And that's done to incentivize people to stay longer and to disincentivize people coming, staking a few blocks, and then leaving. There's also a few attack vectors that have been identified with proof of stake that also helps. If you were a proof of stake validator and you have a stake of Ethereum in there, that stake can be cut or slashed, we call it. So whereas in proof of work, if you're on a proof of work blockchain like Bitcoin, when you're interacting with it, you don't lose Bitcoin. You only have the option of gaining Bitcoin or not gaining Bitcoin. In a proof of stake system that we're developing, you can gain Ether, not gain any Ether, just have it stored in there, or you can lose Ether. If you're caught cheating, if you're caught doing a double spend or whatever the equivalent in Ethereum of a double spend would be, or trying to fake transactions or change a block after finality, your part of your Ether is slashed. Usually for really bad cases where it is very mathematically provable that you're trying to do a takeover of the blockchain or revert a transaction, you get 1/3 of your Ether slashed. So if we take the prices of that today, that's a lot, I'm guessing. So like that'd be 333 Ether times $80. So you'd lose $26,000 to attempt to take over the network. As you keep trying to do that, the costs are going to get higher and higher. So this whole game of crypto economics is just how high can we set the price so that it disincentivizes attackers from attacking us in the first place? If you have a mathematically significant chance of losing Ether if you try to attack us, you're going to have a lot of Ether to get your way, reverting a transaction or putting in bad data. And that's the whole goal of making this Casper system.
All right. Well, I think everybody knows everything they need to know about Ethereum to get started now.
Awesome. Okay. Well, and if you don't, there is a subreddit. It actually will pull up now. This is where most of the conversation around Ethereum happens because we don't use the forums anymore. This is for more general public. There's some tech questions asked and answered. The Stack Exchange is another good resource. And then if you're very into development and want to kind of go to the straight to the developers to ask questions, most of our repositories have Getter chat rooms, including Solidity. So if you're interested in that, there's people talking about questions all the time. For most of your basic questions, the Stack Exchange has 5,700 questions, and way more than 85% of them are answered. So any question you didn't get to ask me tonight, the Ethereum Stack Exchange should have it. And then of course on the, if you do go to the Reddit, go to the Welcome to Our Ethereum, and that's going to have a list of links that give other types of explanations and videos and resources.
Sounds good.
Thank you very much.
Thank you guys. Had a great time, and thank you so much, Jameson, for having me, and awesome first name once again.
Yeah, well, hopefully we can meet up. You said you'll be at Consensus, right?
Yes, we're going to be having a really awesome announcement there. I'm going to be with the Project Oaken team. So I won't be there in capacity of Ethereum Foundation, but come say hi to me and the guys from Project Oaken.
Will do. All right. Thanks for sharing your time and your expertise with us.
Hey, thanks so much, guys. Y'all have a good day.